Hi, my name is John Krochmalny, and I have developed these visual tutorials to accompany any training format that might be delivered. In this presentation, we'll explore electrical symbols commonly used in drawings and schematics. We will also explore electrical drawing elements associated with electrical technology. There are two learning outcomes associated with this presentation. Number one, identify electrical symbols, and 2. Relate symbols to their component function. As mentioned in an earlier presentation, there are three components making up electrical circuits: power sources or supplies, loads, and conductors. Notice the graphic shows an electrical diagram showing these components. 120 volts AC is the source of the power applied to a load that offers 120 ohms of resistance. The solid lines connecting the load to the power represents the conductors. The purpose of electrical drawings involves the communication of ideas between people. The drawing becomes a type of memory that can be given to others to use for installation, service, and maintenance. Symbols are used in electrical drawings to provide readers with an understanding of how the circuit is constructed and what materials are used. Since all electric circuits involve power supplies, loads, and conductors, these devices have symbols that appear on drawings. Many of the symbols are featured on this graphic. Starting with circuit power supplies, here are examples of how these devices are pictured. Power sources provide for that voltage pressure difference needed to initiate a flow of amperage. Whether a battery, transformer, or voltage coming from a power line, these will be shown on electric drawings. Electrical loads convert electrical energy into other energy forms. The identified area shown shows the symbols used for the loads. Typically, a load is shown as a circle with further information added. A symbol of a circle having an M indicates a motor. A symbol of a lamp is shown as a circle with diagonal lines, similar to light rays. In this case, the W indicates a white lamp. Resistors can be shown as either a circle or a zigzag line with a resistor indication. Conductors are those electrical circuit elements that connect loads to their source of power. Remember that power sources supply the voltage difference needed to power a circuit. The load having resistance converts electrical energy into other forms. It is important to know that conductors do not have any resistance, but offer a pathway for the flow of electrical energy. Conductor symbols are identified as a line. This line could be electrical wires of varying thicknesses and styles. Many times, drawing lines indicating conductors will cross or terminate to each other. An intended termination or connection will be identified with a dot. Also, terminals will also be used as convenient ways to connect wires together. Perhaps we have seen electrical wires connected to each other using wire nuts. In industrial panels, terminals and termination blocks are used for conductor connections. Terminal blocks are mounted to rails and have two terminals that conductors can be mounted to. Notice that each terminal screw is connected together by a metal conductor. In so doing, whatever voltages exist on one terminal is also the voltage on its mate. Using a continuity tester, we can see a connection or continuity between screw terminals of each block. Terminals and terminal blocks make it easier for technicians to perform troubleshooting, servicing, and maintenance on electrical panels. Conductors are more than just wires in circuits. Switches are components that control the voltage and current in electrical devices. Figures A and B are the symbols for maintain switches, which keep their position when moved. Figures C and D are symbols of momentary switches, or push-button switches, that will return to an original position when released. Also notice that each switch has a normal position. Figure A and C switches could be a start switch which activates a device when it is operating. Figures B and D could be a stop switch which deactivates a device when it is operated. In this graphic, we see the symbol of a limit switch, and notice how different this symbol is from a common switch. Also notice how each are drawn. Figures A and B on the left show normal positions. Figure A needs to be bumped to close the switch. Figure B needs to be bumped to open the switch. Figure C and D on the right show a held position. Figure C shows a normally open limit switch that is held closed. When the material is moved away from this switch, the switch opens. Figure D shows a normally closed switch, which is held open. When the material is removed from the limit switch, the switch closes. We can apply some of the principles learned in the limit switch with other types of switches. In this graphic, we see the symbol of pressure switches. This pressure switch is indicated with a flat surface or diaphragm that the pressure acts against. Temperature switches or thermostats have this symbol. Notice that the thermostats can either be cooling or heating temperature switches. Heating switches upon temperature fall make. The cooling switches make upon temperature rise. Float switches will have a ball as an operator similar to what is found in a toilet tank valve. The float switch can be drawn to achieve 4 different operations. Finally, when we want to control electrical circuits with flows of fluid, we can use the flow switch. The flow switch symbol has a type of sail that is in the fluid and deflects according to flow. Contactors and starters having contacts as part of their construction. Contacts have 2 positions, normally open and normally closed. The symbol of the contact is shown in this graphic. Remember that conductors are those devices that connect loads and power sources together. It will be important to understand that the term lines can also be used in the place of conductors. Line devices include the various types of switches used in electrical circuits. Also remember that lines or conductors are not considered to offer any resistance to the circuits that they're wired into.